Alright, now we discuss how pi can be viewed as a variable, because they tell us when we go to school, or UTI should note this, because sometimes you look at the mathematics they're teaching us and you think to yourself, well, that's complete bullshit, man. Intuitively it doesn't make sense. So they say pi is a universal constant that only applies to circles, and I found a way of making the concept of pi spread towards other geometric shapes. I'm not really going to show you my equations, obviously. I don't know if they've invented it yet. But just know that I can stretch the concept of pi, and I found different values of pi's for different geometric shapes. This is a nice website that calculates all the different variables concerning a plane geometry. I've chosen equilateral triangles. It's called Calculators Soup. It's quite a nice website. I just found it now anyway. So look at the equilateral triangle. Fuck, man. Obviously K in here is the area, P is the perimeter, H is the altitude or height. Now for any given height, let me choose height, yeah, I could prove that there is a value of pi for equilateral triangles that's different from 3.14. So if I choose a height of 2, yeah, this is the triangles we're doing, a height of 2, and I plug in 2 here, yeah. Now if I set my pi to 3.14, yeah, it tells me that the area should be 4.1, yeah. If we calculate, yeah, what is it the area was again? K is the area, yeah, it should be 2.3, because if we go back to it, yeah, the area is K 2.3. So if we do that again, yeah, and you pick, oh, hold on one second as it sets itself. Wait, so there you go, altitude, yep. So if we set the height for 2, yeah, remember K is the area, so this value here is the area. Give it a second. It's 2.3. So 3.14 is nowhere near the area if you're to use it to calculate pi for equilateral triangles. I've got the exact value, don't worry about it. Let's try a number like 2. If you put 2 in there, it will give you 2.6, so it's getting closer, yeah. If you put 4 in there, yeah, it give you 5.3, so that's nowhere near. But the exact value of pi is this one here. Copy and paste that there. I don't know what that means, but anyway, I pasted it. You see, when I put that value of pi in here, this changes to 2.3, like K here, yeah. And I'm gonna keep this value the same, and I'm just gonna change this, but I won't change that. Remember that value is here. If I do any height, let's say 7, yeah, it gives me an area of 27. I'm gonna keep that the same. I'm not gonna move it. It's always looking like that. So let's go here to verify, because they do it the straight way without using the concept of pi. 7, I should expect the area, this bit, to be 28. Come on, I'm live. Not live, okay. Yeah, 28.2901 or thereabouts. But remember, I've kept this value the same. If you don't believe me, we can go to, like, pick a number randomly. It's going to be a bit big. 1, 2, 4. Oh, I don't know. Yeah, 8, 7, whatever. 887. So if we verify here, 124, calculate. Oh, sorry, I put 125. Oops. 124, calculate. Embarrass me in front of people. 8877. Yeah, but remember, this value has stayed the same. If I was to put it on 3.14, yeah, hang on. If I put it on 3.14, it becomes wrong again. If I put it at 2, it becomes wrong again. It's nowhere near that. If I put it at 3.8, it's way wrong. Yeah. If I put it at, I'll put it back at the right value. Yeah. Only when it's at the right value of pi, which I selected, I won't tell you how, does it give the right answer for any height, which I'm treating as the radius here. So this is the value of pi for any given equilateral triangle, for any equilateral triangle of any given height. You know, with pi of a circle, all you need is the radius, and you'll be able to find the circumference and the area. For equilateral triangles, all I need is the height, and I'll be able to tell you the area and the perimeter. Perimeter is P. So if we, which is I put it here as that, right? So if we put 124 in there again, yeah. Remember, perimeter is P. Yeah. Calculate for a given height. Yeah. Oh, hold on. 124. Yeah. That works out as, we're looking for P, remember, perimeter, 429, 429. For any given equilateral triangle, if you give me the height, I can use my value of pi to tell you what the area and circumference is, just like I would with a circle. So that's the whole point. So R for equilateral triangles is the height. The equivalent of the radius of a circle is the height. For squares, I found that the equivalent of the radius of a circle, is what's it called? Is the height radius, or height or base, it doesn't matter. Like a square has a height and a base, yeah? So if you take half of the height, yeah, that would be the height radius, I call it. So the height, so if the square has a height of, let's say 4, the height radius will be 2. It's half of that. Yeah. If I actually put here equals height divided into 2. Yeah. Right. The height of a square, i.e., if that's a square and the side length is the height, yeah. So if the height A is 4, yeah, the radius I'm using is half of that. And for any given area of a square, you should be able to tell the area. For any given side of a square, you should be able to tell the area. The area is A. So this one is the area, perimeter, and so forth. So if we put this the square side as 4, the area should be 16, because 4 times 4 is 16. But this is where it gets tricky, because what I'm using for pi is that the area is 6.9. If I use 3.14 as pi. Give me a second. The area becomes 12.56, which is nowhere near. But the exact value of pi for squares is 4. Because if I use 4, 16 area and perimeter 16. If I was to change the height to, let's say, 8. Now remember, I told you that the height for squares is the side pointing upwards. A, yeah? So if I was to change that to 8, my formula is telling me with this pi, the area should be 64 and the circumference 32. Yeah? So if we change that to 8, yeah, calculate that. Come on, don't embarrass me in front of people. P is the perimeter, 32. Yeah, check. And A is the area, 64. It won't work for the normal pi, which is only reserved for circles. Yeah. Yeah. It won't work for those. It will give you 50 and 25, which we want 32 and 64. Yeah, like there. It won't work for any other number like 6. Yeah. It gives you 96, 48. We want that. Okay, you could say, but I was going to guess the correct answer. 2. My next guess was going to be 4, and that would have been correct. You get 32, 16, which is not right. So 4, I got that by guessing. You get area, 64, circumference, and it could be for any height. If the height, yeah, remember the height, the A value, if that height is, let's say, 23, and the radius and the pi is 4, I get that. Yeah. So let's put that as 23. Yeah. 92 circumference. 92 circumference. Ooh. 529 area. 529 area. For 4. But for any other value, it doesn't work. Come on. Yeah. So it doesn't work, right? So that's how I've discovered that pi, you can view it as a constant for a circle, but every other geometric object, because once you've done a triangle and a square, every other geometric shape is possible to make with those. So it's easy to find the pi of any shape. That's a secret how I know that. But I've now proved that pi is actually a variable. It's a set of numbers. A set of numbers, you might as well call that a variable. Okay? With respect to shape, where it varies with shape, where the variation is the shape. I don't know what it means, I was just having fun. But there you are. Alright? So pi is a variable. Thank you very much. I won't give you my equation. I don't know if I should put it up.